welcome back to Chemisphere channel. I am Chandan Biswas, and in this video we are going to learn about quantum numbers. Now, what is a quantum number? Quantum number is just like the PIN code. You must have a PIN code, right? Let's say, for example, you have a PIN code of 700006. So now what does it mean? Now, these set of numbers actually mean three different things.
The first digit refers to the region of India, the next two digits will refer to the district, and the last three digits refer to the postal office, which is near your house.
And that's how every letter reaches to you without even first writing down the details of your address. So similarly, we assign some numbers to each and every electron inside an atom. These numbers are called quantum numbers.
Now, since each electron has its own set of 4 quantum numbers, it really helps to identify which electron we are talking about, which is mostly like the GPS location of ours. We all have a unique GPS location at this point of time. Similarly, electrons also happen to have its own GPS coordinate, which is nothing but the quantum numbers. So it is impossible to confuse one electron with another.
Basically, quantum numbers are a set of 4 numbers. Each number of the set corresponds to something very specific. These 4 numbers are called principal quantum number, azimuthal quantum number, magnetic quantum number, and spin quantum number.
Now, before we start explaining the quantum numbers, it is important to understand the structure of atom. The structure of atom is divided into 4 levels. The first one is shell. The second one is subshell, which lies inside the shell. In subshells, we have the third level, which is called the orbitals. And the fourth level is what we have in the orbitals, which are nothing but the electrons. These hierarchies make up the entire structure of the atom. And these 4 hierarchies are explained by their individual quantum numbers set. The 4 values correspond to the 4 different levels.
The first number, which is principal quantum number, it means the shell of that electron. We know that every electron lies in a shell, right? So every shell can have its own quantum number, starting from the first shell. The first shell has quantum number of n equal to 1. The second shell has n equal to 2, and the third one is called n equal to 3, where n is nothing but the principal quantum number. So in theory, this principal quantum number can go from 1 to infinity. We can also have a lot of different information by just knowing the principal quantum number. The first thing is the angular momentum of an electron. Angular momentum is given as nh by 2 pi, where n is nothing but the principal quantum number. Similarly, we can also count the number of orbitals. If the principal quantum number is n, the number of orbitals is given as n square. Each orbital can have at max of 2 electrons, so we can say for sure that every shell can contain at max of 2n square electrons. Let's move on to the next quantum number, which is azimuthal quantum number. Now, what is azimuth as a word? Azimuth in English means direction. So you can say it directional quantum number, maybe, yeah. But also know that this quantum number is also known as angular momentum quantum number. Also, it can be called as subsidiary quantum number. So there are 3 names for the same quantum number, so you can use whatever you like.
The values of azimuthal quantum number are limited to 0 to n-1, where n is the principal quantum number.
Azimuthal quantum number depends on the value of principal quantum number. It cannot go beyond it. It can go maximum 1 less than the principal quantum number. That's why 0 to n-1. For example, if we say that if n equal to 1, then L can be only 0. If n is equal to 2, then L can be taken as 0 and 1, and so on. It's always 1 less than that at max.
The values of azimuthal quantum number also denotes the subshell any electron is in. For example, if L is equal to 0, it corresponds to S subshell. If L is equal to 1, then the electron corresponds to P subshell. If L is equal to 2, then it corresponds to D subshell, and if L is 3, then it is F subshell. So it is pretty clear that each value of L also denotes the shape of different orbitals. For example, S subshell is spherical in nature, P subshells are dumbbell in shape, D subshells are double and different shapes, while F subshells are of much more complicated shapes. So each subshell has its own unique shape, and that is represented by the L value. We also get an information of orbital angular momentum. This value is given as h upon 2 pi into root under L into L plus 1.
The third quantum number is magnetic quantum number. In magnetic quantum number, we get to know what orbital is electron in.
Each orbital has its own magnetic quantum number, and magnetic quantum number depends on the L value. Its range of values extends from minus L to 0 to plus L, which is total of 2L plus 1 values. For example, if we have L equal to 1, then the possible values for M could be minus 1, 0 and plus 1. If L equal to 2, then M value could be minus 2, minus 1, 0, plus 1 and plus 2. Similarly, these boxes represent one orbital, and each boxes have their own electrons. Each box also represents what orientation is an orbital in. For example, if it is minus 1, 0 and plus 1, these three numbers can denote px, py and pz respectively. If the electron is in S subshell, then the magnetic quantum number will be 0.
And lastly, we get to know about the spin quantum number. In spin quantum number, we get to know if the electron rotates clockwise or anti-clockwise, and that spin is given by spin quantum number. So it can have at max value of plus half or minus half.
An electron spins around its own axis, much in a similar way as Earth spins around its own axis while revolving around the Sun. In other words, an electron has, besides charge and mass, an intrinsic spin angular momentum. The direction of spin of the electron can have two orientations relative to the chosen axis. It can be taken as upwards or downwards. Upward direction can be related as clockwise spin, and downwards can be taken as anti-clockwise spin. Now, clockwise and anti-clockwise are completely relative because just like Earth seems to rotate anti-clockwise if you observe it from the North Pole, but the same Earth looks clockwise from the South Pole. Similarly, electron spin can also be taken as arbitrary directions depending on from where you see. These two spins, the clockwise and anti-clockwise, is what gives us the spin quantum numbers, which also shows that any orbital cannot hold more than 2 electrons. And those 2 electrons are said to have opposite spins, spin up or spin down.
So these 4 quantum numbers respectively mean this. The first quantum number denotes the shell. The second quantum number denotes the subshell. The third quantum number denotes the orbital, and fourth quantum number denotes the electron in that orbital. So that's it. These 4 values are the quantum numbers. If you like this video, do give a thumbs up on the video and also subscribe to Chemisphere channel. I'll see you in the next one. Bye-bye.